Hi guys. Well, that's the second part of the GNSS Repeater series. As I promised, this will be the ElCheapo version, the low-cost version of the repeater. As you can see it here already. Let me make it smaller. It's, I don't know, $25, $20, something like that. Shipped mini repeater. That's not really a repeater, and I explain you why. It consists of two parts. First part is the repeater itself. This is this thing. You see inside how it looks. And a rather good active antenna that is both for GLONASS and GPS, for both two GNSS systems. And it works. It has almost 30 dB amplification. This is really nice gain. They say it goes 1 meter or 2 meters. Bullshit, sorry for saying that. It is not much more than 30 centimeters that this thing will work. Yeah. And yeah, you will see what I mean. Here I have my USB receiver again. It is locked. It has a 3D fix. I'm getting a PPS pulse. That's the antenna of it, and that's the repeater. So 30 centimeters, 40 centimeters, something like that. At this distance, it works. It will work perhaps 50 centimeters, yeah? But the signal will be lowered significantly. Let me show you what I mean. So here you can see how this thing works. Already, at this distance, at 30-40 centimeters, we have a reception, we have a 3D fix, but nothing near that it was with the other GPS repeater, GNSS. It's a GPS repeater, even with 5 meters distance. So this thing is really only for small distances, and it is only GPS. GPS, GLONASS, GPS, Galileo, and Beidou. All the E1, L1, G1 frequencies. 1575.42. No GLONASS. Even that the active antenna, as we will see, is capable of GLONASS. So first, let's have a look of the schematic of the repeater itself. It's completely reverse engineered. Let's open it. Boing. Everything falls apart. So this is how it looks. Where it's better to see like that. This is the transmitting antenna, the patch antenna. This time, this antenna is used not for reception, but as a passive transmitter antenna. Not a big amplification, not a big efficiency, but it works. Here we have the input of the, let's say, the input of the active antenna. And let's continue to the circuitry. As I said, that's the SMA input of the antenna, of the active antenna. Again, let's make it a little smaller. Yeah. Again, we have the biasing for the active antenna, the supply for the active antenna, the 5 volts. It's limited with a 150 ohm resistor. And then we have two absolutely identical common emitter transistor stages, amplifier stages. The first one is the pre-amplifier, that the collector goes, the output goes to the SAW filter, surface acoustic wave filter, that is very, very narrow, 1.575 gigahertz. I have no real data about that, but it is very narrow because I don't see anything going through in means of GLONASS, that is 1600 megahertz. After that, and with a lot of loss, or I don't know, because I don't have datasheet for that, again, a common emitter amplification circuit. Both transistors are the same. It's a BFG 425W, Philips NXP, high frequency transistors. And the output goes after a capacitor to the transmit antenna. And here you see it. This is the SAW filter. This is input, amplification. This is the first transistor, the Q2. The SAW filter, output of the SAW filter, second amplification. That's the, what did we say it is? The Q1. And it goes directly through a capacitor to the transmitting antenna. That's it. That's the whole repeater for this ElCheapo unit. Well, that's not a repeater. This is the schematic of a cheap Chinese active antenna that is repurposed to a repeater. That's all. So instead of this output to go to the GPS receiver and this patch antenna to go here, they reversed it. The power comes from the USB. Forgot to show you that. And that's it. This is more or less the design of cheap Chinese antennas that consist only of transistors and a SAW. And many of them do not even have a SAW filter. It is bridged, so everything goes through. Well, I don't have much more to say about that. This is the ElCheapo transmitter unit, repeater unit. With that in the kit, as I told you, it comes with an active antenna that is surprisingly quite good. Look. This is the design of the antenna, and we already see it's a different ballpark. Here we have two dedicated LNA, low noise amplifier ICs, and a and a dedicated good one SAW filter that is for both for GPS and GLONASS. You want me to explain it? Okay, let's explain it. It is antenna in, patch antenna in, first amplification. We will see how much it is because I will show you the datasheet. Blocking capacitor, SAW filter, that is for both, that goes from 2 megahertz. We will see that in the datasheet. That covers both GLONASS and GPS. After that, because of the insertion losses, a second stage and out. And here we have the whole thing is of course powered through the SMA connector from the receiver, and it goes through two inductivities, two inductors, blocking inductors, more RF blocking inductors to the first and second stage. That's it. Really nice, and it works good. So honestly, only this antenna is worth the money. The repeater, yeah, it's not a repeater, forget it. I don't know for what would I use that here. Fact is, the first one, that this goes to up to, I don't know, less than 5 meters, is not acceptable for my needs because it's not transparent enough. I want a repeater that gives me all the 1 frequencies, G1, E1, L1, and B1, Baidu, and not to have to make compromises. So I will not use the first one, I just have it. I opened it, I'll show it to you how it looks. This one is absolutely no discussion to use it. I will use only the active antenna, because this one is good. So let me show you the parts of this active antenna, because the other parts of this crappy ElCheapo mini repeater are not interesting at all. First of all, we have the amplification chip, and this is a good one. Look at here. There is a max 2659, and there is an MS 2659. Both of these chips have similar characteristics, but different pinout. The Maxim chip comes in a DFN package, very, very small package, leadless, where everything is on the bottom, like that. So you can only solder it with hot air, and you don't see if it worked or not. These are a little pain in the ass, but okay, it works. And the clone, in my opinion, that is used. Let me open it. Look, I forgot to show it to you how it looks. So we have here, where am I? Here. That's the first amplification, second amplification, and, sorry, where is the SAW filter? Oh my God, where is it? Do you see this small chip? It is a 1x1 millimeter or 1.5 millimeter. I cannot even bring it closer because I cannot focus it. This thing has 5 pins on the bottom, and it is the SAW filter. This is how small they make it, and even smaller. This is a little bit a challenge to solder, but it works. I've soldered many of those. Oops, sorry. So these are the 2 LNAs, the SAW filter, and the rest is the passive, the passive stuff. The only thing that they made, you will say, where are the inductors? Well, inductors are labeled C4 and C2. These are this one. I need a microscope. C2 and C4. I don't know where they put it, like capacitors. These are inductors. These are these 2 inductors. Back. These are this inductor and this inductor. So this is more or less, not more or less, this is exactly the active antenna with 30 dB gain. A very nice one, because it has quality components, not that crappy old design that they use just with 2 transistors. But again, look at this thing. I don't know how to show it to you. All these passive components are 0603. So it is a size of not even, or 402. So let me show you how it looks. So this is the used LNA amplifier. I like it. I would check where I can find it, because it is cheaper than the Maxim and easier to solder. And this thing is the SAW filter. You see? It goes from 1559 to 1065. It's the complete frequency range for GPS and GLONASS. Compass, I don't know what compass is. I have to check. Anyway, it is very small. Look at that. It has 5 pins in this configuration. And it is, let me show you how large it is, 0.9 millimeters by 1.1 millimeters. This is the size of this thing. Nice components, both the SAW filter, Sun Tzu, for the Asian market, and the LNA is for the Asian market too. But both are quality products and they work very good. So, what we have now, I covered both this ElCheapo combi, that the active antenna is very good. There's the repeater is crap, but it works more or less for 30-40 centimeters, as you saw before. Both of that are no solution for me. So, as always, I decided to design my own. I'm not ready with that because, yeah, I was lazy. I just populated part of the PCB. This thing is a variable and adjustable gain one-port repeater that goes from, oh, I forgot, from 2 dB amplification. This is of course not, this is just a preview what I'm showing to you. It's completely for E1, G1, L1 and B1, Compass, GLONASS and Baidu GPS. Input will be an SMA connector. Output will be an TNC connector. And on the TNC connector, I will use this. So let me open it. Took me a while to find one that is not expensive. This thing is a passive, high quality, military grade L1, L2 GPS antenna. Dun, dun, dun. Oh. And this thing will be the passive retransmission antenna that will be connected like that when it's finished. And it will be directive, not like the helix omnidirectional antenna, but a directional antenna that beams the complete signal to a narrower angle. So this is how it will look. Look at that. 16th December of 1995. Of course it's not new one. I think it's from an aircraft. I don't know. I like it. It's completely new. Brand new. So this is what will come in one of my next videos. Adjustable to a higher amplification, and I shouldn't say that, but with quite the power. This thing will have a lot of dBms, but it can be adjusted. It can be adjusted down. The idea is that you can use it for large rooms without any problems, not with like the other toys. So this is the prototype, the 0 prototype. Already I want to make a new one because I found some errors in the microstrip calculation here. I want to make the exposed parts with ENIC gold. Yeah. The second thing what I want to tell you is that only as an indicator, I'm using a U-blox, or a fake U-blox Chinese clone chip, just to show me that the whole system has reception. Here will be a small receiver. It costs, I don't know, $2, $3, I don't know what. And this will show me the PPS signal. When the PPS signal and this thing has an fix, that means that through this microstrip line, we have a signal output. For that I will use an antenna that resides above this part. Yeah, 12-volt power supply, and that's it. That's just a teaser. Anyway, I see that this one is a little shorter, this video. This is the way I will go. I will not check any other one to find something cheap on eBay, etc. I don't care. I design my own. This is the smallest part I've used till now. It is a highly integrated dual LNA pre and post amplification. It has a pre-amplification LNA. In between it has a double SAW filter for both of the frequencies, the GLONASS and the 1 frequencies, and an output, a post LNA. It has a lot of stuff. It is very, very, very small, 3x3, I think, or something like that. Again, the C5 is a 0603. And it is a chip that has no leads on the side. There's everything on the bottom. Doesn't make it easier. The chip that's missing is a variable voltage-controlled attenuator. And the other chip is a power amplifier. But you will see these things when I finished with the testings. The rest is just, I need 3 voltages, 8 volt, 5 volt, and 3 volt, I think. 2.8 volt, sorry, for the different stages. So, that's for today. If you want more informations about this GPS stuff, if you want some more information about RF over fiber, RF over fiber design, etc., let me know in the comments. And if you like what you see, if you like my videos, please subscribe my channel, press the like button and the notification button. All these things help me to make more videos like that and to show you more hopefully interesting stuff that I have made or I will make, etc. I don't think that it will be a part 3, and if it is a part 3, it will be that. So guys, thanks again for watching. Look how nice it looks. See you in the next video. Cheers, bye.